Have you ever sat on a physiotherapy table with a warm heat pack on your back, or maybe you felt that deep rhythmic hum of an electrical stimulation machine and found yourself wondering, how exactly is this actually helping my pain? We almost always think of physical therapy purely in terms of muscles, joints, and stretches. But what if I told you that to truly understand how these treatments heal you, we have to zoom all the way down to the quantum level? Seriously, what does quantum physics have to do with healing a sore muscle? Well, the answer is absolutely everything.
Welcome to The Explainer. I am so excited to guide you through this material today. We are going to trace this incredibly fascinating journey of therapeutic energy. We're starting from the incredibly tiny, microscopic atom and scaling all the way up to the macroscopic healing of the human body. We'll be looking at the core physical principles that power all these electrophysical agents, and we're going to keep it to clear, simple concepts. No getting bogged down in complex math today, I promise. Okay, let's dive into this.
All right, so here is our quick roadmap for today's explainer. First, the invisible building blocks. Second, making things move, energy. Third, the physics of heat transfer. Fourth, electricity meets the body. And finally, high-frequency healing therapies. Let's kick things off with Section 1, the invisible building blocks. Take a look at this beryllium atom. Right there in the center, we have the heavy nucleus, which is made up of protons and neutrons. But honestly, the real main character of our story today is the electron. These negatively charged particles are constantly revolving in definite orbits around the nucleus. And even though an electron is literally incredibly tiny, we're talking only about 1/1837th the mass of a proton, its movement is everything. It's the movement of these outer electrons that eventually makes an electric current possible, which is the absolute foundation of all electrotherapy. Now, while we're talking about atoms, let's quickly demystify a term you'll probably hear a lot: an isotope. Sometimes an atom has its standard number of protons, but a completely non-standard number of neutrons sitting in the nucleus. All this really does is make the atom heavier or lighter. Its mass changes. But because the chemical activity of an atom is almost entirely run by the number of those orbiting electrons we just talked about, an isotope behaves chemically just like a standard atom. So just remember, whether we're dealing with standard atoms or isotopes, the electrons are always the ones driving the electrical conduction. Okay, what's really interesting about this is that we're literally looking at the birth of electromagnetic radiation. If you add energy to an atom, say by heating it up, you can actually force an electron to jump outward into a higher energy shell. It gets excited. But it doesn't want to stay up there forever. When it finally drops back down to its normal orbit, all that extra energy has to go somewhere, right? It gets released as this tiny, tiny pulse of electromagnetic energy called a photon. And as billions of electrons do this all at once, they emit waves. Depending on the energy level, we might see this as visible light, or, and this is crucial for us, we might feel it as therapeutic infrared heat.
Moving right along to Section 2, making things move, energy.
So matter is basically locked in this constant, massive tug-of-war between two forces. You've got the cohesive force trying to glue molecules together and kinetic energy, which is essentially physical jiggling, trying to pull them apart. In a solid block of ice, cohesive forces totally win, keeping everything rigid. But if we add energy to the system, like therapeutic heat, the kinetic energy goes up. The molecules start to jiggle faster and faster until they break those rigid bonds and become a liquid, just sliding right past one another. Add even more heat, they fly apart entirely and become a gas. It's a beautiful, straightforward physics concept. No complex equations required at all, just visualizing the addition of that kinetic energy. But there is a really fascinating catch when matter changes its state, and it's known as latent heat. You can kind of think of this as a hidden energy tax. To change just 1 gram of ice at 0 degrees Celsius into water at 0 degrees, it takes a highly specific amount of energy, purely just to break those solid bonds. The actual temperature doesn't go up during the melting process. Every ounce of that energy is used just for the state change. And get this, the exact reverse is true. When a liquid turns back into a solid, it releases that hidden energy tax right back to the environment as heat. So why does this matter to us in a clinic? Let's look at a super practical application: paraffin wax therapy. A therapist dips your hand into warm liquid paraffin wax. As you pull your hand out, the liquid wax almost immediately begins to solidify on your skin. And as it changes from that liquid to a solid state, it releases its latent heat directly into your body. This hidden energy transfer is the exact reason why a paraffin wax treatment gives you such a profound, deep, long-lasting tissue warming. It's atomic physics literally at work on your sore joints. Which perfectly brings us to Section 3, the physics of heat transfer.
In physics, there are three primary methods of heat transfer, and honestly, each one anchors perfectly to a very specific physical therapy treatment. First up is conduction. This is where heat transfers through direct physical contact, like literally just placing a solid hot pack right onto a sore lower back. Second is convection, which is all about the movement of a fluid, so either a liquid or a gas. We see this all the time in warm whirlpool baths. And third is radiation. This is where heat is transmitted through those electromagnetic waves we talked about earlier, passing right through space without needing any medium at all. Think of the soothing warmth of an infrared lamp. And this brilliantly illustrates exactly how convection works. When the fluid at the bottom gets heated up, the molecules get that kinetic jiggle, right? They move further apart, and that specific portion of the fluid becomes less dense. Because it's suddenly lighter, it rises to the top, which then displaces the cooler, heavier fluid, forcing it to sink down and take its place. This continuous rolling cycle creates convection currents. When you're sitting in a therapeutic whirlpool, it's these exact physical currents that are actively circulating the warmth uniformly all around your injured limb.
All right, moving into Section 4, Electricity meets the body. This is where biology and physics really collide.
The absolutely crucial thing to wrap your head around here is that, electrically speaking, the human body is not uniform at all. The outer layer of your skin, the epidermis, is tough. It has a relatively high electrical resistance. Basically, it really doesn't want to let a current through. However, your deeper tissues and things like your sweat glands are incredibly rich in fluids and ions, which means they have a much lower electrical resistance. They act almost exactly like highly conductive wires just waiting to be tapped into.
So in physics terms, your body acts just like an electronic component called a capacitor. Think of your skin as a bouncy castle wall, a dielectric layer if you will. It sits right smack in the middle between the low-resistance electrode pad on the outside of your body and the low-resistance deep tissues on the inside. Because of this tough, resistive wall, a long, continuous, direct current is really going to struggle to get through, and it mostly just ends up dumping all its energy right into the skin. But short electrical pulses or alternating currents, they can jump right past that barrier and flow beautifully down into the deeper tissues. Let's wrap up our core concepts with Section 5, High-Frequency Healing Therapies. So, the big takeaway is that therapists are choosing specific electrical frequencies entirely based on this physics of tissue resistance. If they want to just treat the surface, they'll use continuous currents that simply get absorbed by the skin. If they want to stimulate a muscle without burning that skin, they'll use short alternating pulses that can slip right past the epidermis. And if they really ramp the frequency up into the megahertz range, well, the current oscillates so incredibly fast that it passes right through the skin and deep into the body without even giving your pain or motor nerves enough time to trigger. This allows for massive, deep tissue heating. Now, I want to talk about one of the cleverest workarounds in all of electrotherapy. It's called interferential therapy. Imagine a patient really needs a low-frequency pulse to relieve some deep muscle pain. But as we know, low frequencies just get blocked by the skin. So what's the solution? We use two separate circuits. We send in one medium frequency wave, let's say at 4,000 Hertz, and a second wave at 4,100 Hertz. Because they're medium frequency, they completely ignore the skin's resistance. But right where those two waves intersect deep inside the patient's body, they superimpose on each other. This creates a low-frequency difference of exactly 100 Hertz. We literally create a slow healing pulse from the inside out. How cool is that?
Another incredible tool we use is microwave diathermy. Because microwaves have such a super short wavelength, they don't spread out everywhere like normal radio waves do. They actually behave much more like a focused beam of light. And this beam is strongly absorbed by water, which makes it absolutely perfect for targeting water-rich muscle tissues sitting deep beneath the fat. According to our sources, these waves penetrate with a half-value depth of roughly 3 centimeters. That brings all that electron-exciting kinetic energy right into the heart of a torn muscle to seriously accelerate the healing process.
So, from the microscopic jump of an electron creating a photon, to that hidden energy tax of solidifying wax, to the incredibly clever crossing of high-frequency electrical waves deep inside your muscles, physical therapy really is just physics in action. By understanding these invisible rules of energy and matter, we've developed some truly remarkable ways to accelerate human healing. So next time you're sitting on a clinic table feeling the soothing warmth of a therapeutic heat pack, take just a second to ask yourself, what are your electrons doing right now? I really hope this explainer sparked your curiosity today. Thank you so much for hanging out with us and keep on learning.